Consider the following statement. There exists a pair of straight lines that are everywhere equidistant from one another. Is this statement a direct consequence of Euclid's fifth postulate? Explain. So, yes, it is a direct consequence. If I consider a straight line, okay, I'll call it as, say, line L, okay, and I consider a point M, which is not on line L, okay, then by Playfair's axiom, there exists a unique line which passes through M and is parallel to L, right? Correct? That is what Playfair's axiom. So, by that I can draw only one line which is parallel to this. So, if this is, I'll call this line as, let us say, I'll call this line also as line M, okay. So, what did I get? I got that lines L and M are parallel to each other. So, if two lines are parallel to each other, then what is the distance between two lines? Okay, if I consider any point on line M, let us say P, okay, then how can I calculate the distance of P from line L? I'll draw a perpendicular line from P to line L and I'll measure this distance. Let us say this is D, okay. If I take another point Q on line M, then if I want to find the distance of this point from line L, then this will also be D. Why? Because these two are parallel lines. So, if these two are parallel lines, I can see that whatever point I select on line M, for any point on M, distance of that point from line L is D, okay. And similarly, if I consider a point A here on line L, then the distance of this point from line M is what? This perpendicular distance, correct? So, this perpendicular distance will be same as the perpendicular distance of this point from this line, correct? So, if I call this as B, then distance of A from M is equal to distance of B from L, correct? Because both of these lines are coinciding with each other. These are parallel lines. So this means that these two angles are 90 degrees, correct? Because that is what is the Euclid's fifth postulate, that if I draw two lines and I draw on the line, then if sum of these two angles is not equal to two right angles, then they will intersect. But if they are equal to two right angles, then we call them as parallel lines, correct? So sum of these two angles is two right angles. Therefore, by Euclid's fifth postulate, I can tell that these two lines are parallel lines. Now, I know the Euclid's fourth axiom, which is things which coincide with each other are equal to each other. So, since these two lines coincide with each other, these two are equal. That is Euclid's fourth axiom. Okay. So, now if these two are equal, then this will also be D. Similarly, if I consider any other point C on L, then the perpendicular distance of this point, then the distance of this point from M, that will also be D. So, as I can see, similar for any point on M, distance from L is D, and for any point on L, distance of that point from M is again D, correct? That means that these two lines are equidistant from each other. Therefore, it is true that there exists a pair of straight lines that are everywhere equidistant from one another. This is true. As we can see, we got that all parallel lines are any pair of parallel lines can be considered as a pair of straight lines that are everywhere equidistant from one another. Is this statement a direct consequence of Euclid's fifth postulate? Yes. Why? Because here the distance of B from line L and the distance of A from line M, they both will be equal only when these two angles are right angles, right? And the sum of these triangles is two right angles is what is the condition that Euclid's fifth postulate tells us for two lines to be parallel.